Okay, so hi everybody, my name is Dorothea and this is Kyle and Vorik, and we are surgical trainer and navigator. So, learning to do surgery or learning how to operate is kind of like learning how to write. You start off with really big, crude, uncontrolled movements, and with a lot of practice, your movements become refined and precise until you can do complex things like minimally invasive or laparoscopic surgery, where we use long tools like this through very tiny incisions to do complicated things like sew up holes in a piece of bone. So unfortunately, right now, we don't have any objective measures of a surgeon's technical performance. All we have is subjective scales like what you see above. And when you get that kind of feedback, it's sort of hard to know exactly how to get better. Some recent research, though, has looked into tracking hand movements as an objective measure of surgical performance. And so far, that's only been done with expensive electromagnetic sensors. So we made an app for that. So our app can track surgeons' hand movements in order to improve technical performance. And how does it do this? So we have Bluetooth sensors that we attach to a surgeon's wrists, which track accelerometer data to give the surgeon feedback on speed, precision, and efficiency of movement. So feedback on speed we give sort of based on how long it took to do a certain procedure or a task. Feedback on precision we derive from a measure of changes in acceleration, and the feedback on efficiency comes from the number of movements made. And now Vorik will discuss in a little more detail how we got precision and efficiency.
Yeah, so as we said, timing speed is fairly easy, it's just time. With precision, we define precision as surgeons' control of their movements and how many changes in accelerations they had in a period. The way we go about figuring this out is our accelerometer data is basically in three parts. It has one for each directional axis, or your X, your Y, and your Z axis. Together that makes a resultant acceleration, which is represented by the red arrow here. By taking the magnitude of sequential resultant accelerations, we have a measure that gives us the amount of change, and we can see how controlled it is. To look at efficiency, we have to define what a movement was, and movement we viewed as essentially a cluster of high changes in acceleration. So we start off with the same calculation as we used for precision, which is represented by the green lines in the background. We smooth that out, which creates the nicer looking red line. And by looking for where the peaks and the valleys are in this, we can figure out where a movement starts and where a movement ends. So each of the blue indicators is where we consider the end of a movement. By adding this together, we can figure out how many movements a surgeon made in a procedure and give feedback on that.
So after a lot of recording, we were able to categorize the results of speed, precision, and efficiency into performance categories, which we labeled beginner, junior, senior, and expert. And these are commonly used terms in surgical training. And then the app can also give category-specific tips. So for example, if you achieved junior level speed on the peg transfer task, it will say, try picking up the next peg with your free hand while putting down the previous one as a tip for how to improve your speed. And so now we'll demo using the laparoscopic simulator and the peg transfer task.
Okay, so as Taya sets up the machine, I'll start off the app. So the user opens the app, starts a new session, and we'll choose a certain option to describe the procedure. Today we'll be doing a peg transfer, and we'll do a practice session type. So Taya, if you could turn on your sensors. All right, sorry about that. We're having some technical difficulties. Let me just restart the app. Here, let me turn on the sensors for you.
Yeah, we found these sensors are a bit finicky, so sometimes they don't always connect on the first try.
Okay, so scan, new, next. So click, there we go.
Okay.
So what we've done is we have a gesture that actually starts the recording because surgeons will be presumably scrubbed and unable to actually touch a screen in order to start it. So hopefully this will work.
I think it's the other way.
This one? Okay, and then I'm going to demo this task. So can you switch to, oh, you did already. Okay, so this is the peg transfer task, and it's part of our laparoscopic, fundamentals of laparoscopic surgery exam. So what I'm supposed to do is pick up a peg with my left hand, transfer it to my right hand, and put it down. And so you do that with each of the pegs. And I'm sorry, I'm a little bit nervous, so this is looking less smooth than it should. And then, and so you're supposed to do the same thing with all 6 of them. Oh. You're not supposed to drop them, yeah. And this is sort of one of our basic tasks for that exam, and something that most surgical trainees start to practice pretty early, like in medical school. And then the task is actually to, after you've done them, sort of transfer them all one way, to then pick them up with your right hand and transfer them all back to the other side. But we're only going to do half the task for the purposes of this demo. Okay, so then what we end up seeing here is the results.
Yeah. So what we see here is what I was talking about a bit before, the first measurement for speed, precision, and efficiency. Obviously, with each category, we have a value associated with it. So your time measurement, your efficiency measurement, your precision measurement. It categorizes you, Taya talked about before. There's the kind of 4 categories of expert, senior, junior, and beginner. So it gives you where you rank compared to the data we have, and also gives you advice to how you might improve going forward. So, so this is the result that a user gets after a single session. We also have from history, again, you can pick, kind of jumping through one scene here, but you can pick again the area that you want to look at. Past cases will let you select from a list a previous session with both the time and date, which will give you the same results that we just saw except for the given session. Or there's also useful to know is how you're improving given over time. So looking at speed here, for instance, we have a chart showing how your progression has been for each session. And we expect, obviously what Taya just did, because it's only half a session, we expect values to be quite good. The different lines show the benchmarks between the different
Performance
categories.
categories.
Yeah. And we have one for each of the 3.
So just to wrap up some of the things that we learned and would do differently.
So one of the major challenges we had here was kind of choosing an appropriate sensor for this app. We need something that is very high frequency and better accuracy. So we learned that we really need to do better research in terms of finding a consistent and stable sensor. Past papers have also shown that distance is used as a parameter for measuring surgical efficiency. We were unable to derive a good approximation of distance, however, because we had some troubles connecting the accelerometer and gyroscope data at an appropriate frequency. And the second thing would be data processing and interpretation. It turned out to be a little more complex than we originally imagined, and having someone who had a stronger signal processing background would have been helped out. And in the future, we'd like to do some gesture recognition, implement some sort of machine learning algorithms into our app, improve the accuracy of calculations, have some more surgical procedures, test our app on lots of experts to acquire more data, and hopefully implement some sort of social aspect where surgeons could share their improvement or progress. Taya?
Yeah, and just sort of a final thing, my vision for this app would be to have it be able to analyze data as it's recording so that it can give you real-time feedback, so that it can warn you, for example, you didn't tie that knot down properly, please do that again to avoid a complication.
Thank you very much.
Yeah, I'm just wondering, when you talk about precision, are you talking about whether your hand is really shaky or whether you make sudden movements when you're doing
So,
like that?
what ends up happening is a movement, because we're looking at the change of movement. When you make a large movement, we tend to, like if I pick something up, there'll be a bunch of accelerations going down and a bunch of accelerations coming up. Now, if I'm nervous, for instance, my hand might be shaking around, so I end up with quite a few more movements. And by doing a calculation on how that adds up, it ends up being larger numbers for. So again, with a precision, somebody who's doing surgery, the smoother the motion, the fewer the motions.
Or controlled is sort of what we're using. So we're assuming, I guess, that a controlled motion has small changes in acceleration associated with it.
I noticed that when you did the task, you came out as a senior level surgeon.
We only did half the task.
Sure. If I came up there and did that, could I also be potentially a senior level surgeon if I came and did that? Would the app tell me that I'm senior level? Or will like me having no experience guarantee that I come out as a junior?
It all depends how good you are. If you're a very fast learner, have very controlled hands, like it all depends on what the data.
So these guys tried it.
Yeah.
Yeah.
And the first time usually takes like 3 minutes. Takes a while for you to figure out how to like move the actual graspers. So I can guarantee you on your first try, you probably wouldn't be an expert, but you might learn it pretty quickly. So by your 10th, you might be an expert. It's a pretty easy task.
Previously, you had some parameters in the application, like the height of the patient and other parameters. I didn't see that in the demo. Did you remove the consideration of those things?
Yeah, so we initially thought that we were going to be able to measure the distance traveled, and that we would have to calibrate by the height of the patient. But because we were actually not able to measure distance, given that we couldn't get accelerations and gyroscope data at the same time, we sort of removed that because it was no longer necessary to calibrate.
Yeah, I was just gonna ask, like, do you think this app could be almost like a replacement to what they currently do to measure someone's performance? I mean, I don't know how it's currently done.
So what I had up there was the scale. So essentially, after my 3-month rotation, surgeons will sit down and they'll say, okay, you were at expectations, or your technical performance was above expectations. And that's all the feedback that I get, really, apart from occasionally somebody saying something in the OR like, why don't you try doing that with your right hand instead of your left, or something like that.
So you can see this as being a more effective score.
Right, a more objective
Okay.
way, yeah.
Great, thank you.